Hey guys, and welcome to this short little video on the normal distribution. So we've come across a distribution graph that looks similar to this before. You might have also seen negatively skewed and positively skewed data as well. What we're going to be looking at is the normal distribution and how it's all set up. So you may recognize the value here as being our mean. What we've got on either side is one standard deviation. So that's one standard deviation away, two standard deviations away is here, and three is over here, and the same up here, except we're adding on standard deviations on the plus side here, and on the negative side we're taking them away. The percentages that we've got here, so this 34.13%, that means that 34.13% of the data lies between the mean and the first standard deviation, or one standard deviation away from the mean. 13.59% lies between one standard deviations and two standard deviations away from the mean, and etc, etc. So whatever happens on one side of the mean happens on the other side. So what we could say is that approximately 68% of the data lies between one standard deviation, or take one standard deviation and add one standard deviation. Approximately 95 is between two standard deviations of the mean, either side of it. So the mean take two standard deviations and the mean plus two standard deviations. And finally, approximately 99.7% of the data will lie in those three standard deviation ranges. And that's really how it's all constructed. So we've got the 2.15%. Anything above that, it's less than 0.3% of the data will lie outside a range of plus or minus 3 standard deviations. So how do we use this in an example? Well, let's just say that we're going to sample cans of tomatoes that taken off of a production line. The contents of each can is going to be measured for weight. What we found in this example is that the mean weight was equal to 486 grams, with a standard deviation equal to 6 grams. So the question I'm going to ask is, what was the percentage of cans with a weight between 480 and 486 grams? So we can see that our mean being 486, we're taking one standard deviation away from it and we get 480. That means that if this part here really lies in here, so we could say that 34.13% of the cans will have a weight between 480 and 486 grams. And that's really everything that we use for the normal distribution. What I want you guys to do is to get a copy of this down and also get this section here down as well. Let's tidy that up a bit. Get that down, and in your books, make it nice and large so you can actually see it, and try and draw it the best you can. Hopefully you've gotten something out of this video. If you've got any questions, just ask. As always, if you've got any feedback, please just let me know. Thanks for watching. We'll see you next time, and bye for now.